Hey guys, so today what I'm going to do is I'm going to go over the review that is for the Unit 8 test that my Math Transitions class has on March 6th, so you can be prepared for that test. As long as you know how to do these 10 questions and do them well, you will be able to pass the test with no problem. The questions are not exactly like the ones on the review, but they are similar. So let's just go ahead and take this one at a time. So number one says rewrite in radical notation. So we have 6 to the 1/2 power times x to the 4/8 power. Now we can tell that 4/8 is not a fraction in its simplest terms. So if I rewrite this, I'm going to have 6 to the 1/2 times x to the 1/2 because 4 over 8 is 1 over 2. So the way I'm going to rewrite this is the square root of 6x. Because remember, the default index for any radical is 2. Number 2 is pretty simple. It just says rewrite this one in rational notation. So that means we're going to go from this radical and put it with an exponent that's a fraction. So remember, anything that is the radicand becomes the base, and that all needs to be in parentheses. If it's not in parentheses, then the exponent will not apply to the whole thing, only to the last term. And remember, what we're going to do is our exponent is going to be our numerator. Default exponents are 1. And our index on this is 5, so our denominator is 5. Not too difficult. So the next one we have is simplify this radical expression. We have the square root of 16a to the 7th over 81b to the 6th. And this is pretty simple. We're just going to break it down. So we have the square root of 16, which is 4 times 4, and a to the 7th, which is a to the 6th times a to the 1st. And then we have 81, which is 9 times 9, and we have b to the 6th. Now remember, when we're doing square roots, any even exponent is a square. We're just going to divide the exponent in 2 and pull it out. So this is a fraction, so we're going to go ahead and pull that out. We're going to keep it as a fraction. So we have a pair of 4s. I'm going to bring that and put it on the top in our numerator. A to the 6th, what we're going to do is divide that exponent in half and also put it in the numerator. We have a pair of 9s, so that goes on the denominator. And we have b to the 6th. 6 is divisible by 2, so we end up with b to the 3rd. But we still have a single a on the inside of the radical, so we need to write radical a. So our final answer, if we wanted to write this a little more neatly, would be 4a to the 3rd over 9b to the 3rd. All of that times the square root of a. So now we have number 4. It's taking the cube root of 27k to the 9th and 3k to the 4th. Now, in this case, we're going to look for our trios instead of pairs, and we want our exponents to be divisible by 3, and any remainder after it's divided by 3 remains inside the radical. So let's go ahead and rewrite this. We're going to write our radical and our index, so we have the cube root. 27 is 3 times 3 times 3, and k to the 9. 9 is divisible by 3, so I'm going to leave it. And then we have 3k to the 4th. So that gives me 3 on the bottom and a k to the 3 times k to the 1, because 3 plus 1 is 4. And now I'm going to pull these out. So I'm going to have my trio of 3s comes out. And we have a 3. K to the 9. 9 is divisible by 3. We're going to divide that by 3. K to the 3. 3 is not a cube, so it's going to stay in there. K to the 1st is not a cube, but k cubed is. So we're going to bring that down to the denominator. And we're going to have times the cube root of 1 over 3k. Now, we're not done with this problem because notice how we have 3k to the third over k. K to the third is divisible by k. So we're going to divide k to the 3 over k. And remember, when we divide exponent, same base, different exponents, we subtract the exponent. So we have k to the third over k to the first. So we're going to keep the 3 as is. 3 minus 1 is 2. So we're going to have 3k squared times the cube root of 1 over 3k. Not too difficult. All right, so that's 1, 2, 3, and 4. Let's go ahead and move on to 5. Now it says simplify the expression into radical form. So we have 2a to the 5th over b to the 6th raised to the 4 thirds. So one thing we can do, we're going to go ahead and write it's the cube root of everything in the parentheses becomes our radicand, 2a to the 5th over b to the 6th, and that is all raised to the 4th power. So remember, our numerator becomes our new exponent, and our denominator is our index. Now in this one, we have 28 r to the 6th raised to the 5 over 6, and all of that over s to the negative 8 over 5. So this one's going to be a little bit more complicated. So we're going to do it in two parts. So note s is a negative exponent, so let's go ahead and do that. So we're going to have 28r to the 6th, and that's raised to the 5 over 6. And we have s raised to the negative 8 over 5. So we have s, oops, sorry about that, guys. We have s to the 8 over 5. Remember, negative exponents become positive and move over the fraction bar to the other side, raised to the 5 over 6. Now remember, when you have an exponent raised to an exponent, you are going to multiply the exponents. So we need to simplify these exponents before we can put it into radical form. So we have 28, 28 is going to be our base, and it's going to be 6th root, and all of that raised to the 5th. R to the 6th over R to the raised to the 5 over 6 becomes R to the 5, because 6 times 5, 6 is 5. And then we have S to the 8 over 5 to raise to the 5 over 6. So 8 over 5 times 5 over 6, 5 and 5 cancel. This is divisible by 2, so that's 3, and this is 4. So the new exponent is 4 over 3. So we're going to have s, the cube root, all raised to the 4th. So notice how we have 2 to the 5th. So what I can do is I can take this r and stick it in front of this. So we have r times the 6th root of 28, all of that raised to the 5th. And then we have the cube root of s raised to the 4th. Not too difficult. Okay, so on number 6, you notice we did distribute that exponent through to each part of the fraction that was in the parentheses. We actually cannot simplify this any further, so we're going to leave it as is. Now, if we could have simplified it further, let's say we had the cube root of 8 as one of our answers, that would simplify to 2, because the cube root of 8 is 2. So we're not going to leave that as the cube root of 8. We're going to put 2. Okay, so let's go ahead and move on to number 7. We have negative 3 times the square root of 27 plus 3 times the square root of 32 minus the square root of 20. So we notice none of these are like radicals, so we're going to have to simplify. So let's go ahead and start with our first one, negative 3 times the square root of 27. So negative 3 goes on the outside, And 27 is 9 times 3. 9 is a perfect square, so we're going to go ahead and pull it out. So negative 3 times the square root of 9, which is 3. All of that times the square root of 3. Negative 3 times 3 is negative 9. So our final answer for that part is negative 9 times the square root of 3. Now we're going to simplify 3 times the square root of 32. And 32 is 2 times 16. 16 is a perfect square. We're going to go ahead and pull that one out. So we're going to have 3 times the square root of 16, which is 4. All of that times the square root of 2. 3 times 4 is 12. So we're going to have 12 times the square root of 2. Finally, we have the negative square root of 20. So square root of 20 is 4 times 5. 4 is a perfect square, so we're going to have 2 times the square root of 5. So our new problem is negative 9 square root of 3 plus 12 times the square root of 2 minus 2 times the square root of 5. Now, all of our radicands are prime, so we can't simplify any of them further, and they're not like radicals, so we can't actually combine them. So our final answer is, in fact, negative 9 times the square root of 3 plus 12 times the square root of 2 minus 2 times the square root of 5. Remember, at this point, if you have any like radicals, you need to combine them as if they were like terms. All right, so we're going to go ahead and move on to number 8. We have the cube root of 5b to the 6th minus 2b times the cube root of 40 plus 2 times the cube root of 135, b to the 3rd. So the hardest one to do is going to be that 135. So let me go ahead and erase some things so I have some room. I'm going to erase all of this. And we're going to go ahead and do this one. So cube root of 5b to the 6th. Now, b to the 6th is divisible by 3. So we have cube root 5b to the 6th. And we're going to go ahead and pull that out. So we're going to have b squared times the cube root of 5. 5 is not a cube, so we have to leave it there. Next, we have negative 2b times the cube root of 40. 40 is, let's go ahead and do the prime factorization of 40. So we have 40 divided by 5 is 8. 8 is a cube, so we're going to use that. So we're going to have negative 2b times the cube root of 5 times 8. And since 8 is a cube, we're going to pull it out. We're going to have negative 2 times 8 times b times the cube root of 5. Negative 2 times 8 is negative 16. So negative 16b times the cube root of 5. Finally, we have 2 times the cube root of 135b cubed. So let's see how that works out. Now, 1 plus 3 plus 5 is 9, so that means that's divisible by 3. So we're going to start with 3 when we factor our 135. So let's go ahead and do the prime factorization of 135. 135, let's see, that's going to be 45 times 3 and 15, and then 3 and 5. So we have 3 3s. So we have, I'm going to erase this, sorry guys. We're going to have 2 times the cube root of 3 cubed times 5 times b cubed. B cubed and 3 cubed are both cubes, so we can pull them out. So I'm going to pull out my 3. I'm going to pull out my b. So I'm going to have 3 times 2 times b, all times the cube root of 5. 3 times 2 is 6, b times the cube root of 5. Now, our final terms that we have are b squared times the cube root of 5 minus 2b times the cube root of 5 plus, let me write that smaller, I'm sorry about that, guys. So 2b cube root of 5 plus 6b cube root of 5. So now let's go ahead and rewrite it so we can use our distribution because we have cube root of 5, cube root of 5, cube root of 5. These are like radicals. So we're going to have b squared minus 2b plus 6b, all of that times the cube root of 5. B squared does not have any like terms inside that parentheses in our order of operations. We always do our parentheses first. But we do have negative 2b and positive 6b. So we're going to combine those. We're going to have b squared, and that's going to be plus 4b, all of that times the cube root of 5. We could write this as two terms as well. So this is an acceptable answer, or we can split it back apart, b squared cube root of 5 plus 4b cube root of 5. Personally, I think this is going to be my best answer because it has the fewest number of things written. But if you were to write b squared cube root of 5 plus 4b cube root of 5, I wouldn't hold it against you. All right, so finally, we have our two questions that are coming from a different unit so that we can be prepared. We have 3x over x squared minus 4 plus 1 over x plus 2 equals 2 over x plus 2. So the first step is to find a common denominator. Knowing what I know, x minus 2 times x plus 2 is x squared minus 4. So we're not going to do anything to that first term. So I need to multiply 1 times x plus 2, and I need to multiply 2 times x minus 2, because that is what this needs, x minus 2, and this needs x plus 2. So the first term will stay the same, 3x over x squared minus 4 plus x plus 2 over x squared minus 4 equals 2x minus 4, all of that over x squared minus 4. Now remember, when the denominators match, they do not matter anymore. We don't need them. What we had last time we did problems like this was some people decided that if the numerators matched, they didn't matter anymore. And that's not how it works. We can't just solve the denominators. We can only just solve the numerators. So we're going to have 3x plus x plus 2 equals 2x minus 4. Combine like terms, we have 3x and 1x, that's 4x, plus 2 equals 2x minus 4. I'm going to subtract 2x from both sides. So that gives me 2x plus 2 equals negative 4, minus 2 from both sides. And we're going to have 2x equals negative 6. Divide both sides by 2. And x equals negative 3. And let's look back up at our top because we forgot to come up with answers that it can't be. So if we look at our answers, x cannot be positive or negative 2. Since x cannot be positive or negative 2, that means our x equals negative 3 is an acceptable answer. So let's look at the next one. I'm going to go ahead and get rid of all of this because I don't need this anymore. So our next problem is x plus 1 over x plus 7 equals x minus 2 over x. Now this one can be solved using cross multiplication. So we're going to multiply them together. So x times x plus 1 is x squared plus x. X plus 7 times x minus 2. That gives me x squared, because I did that. X minus 2 minus 2x plus 7x minus 14. Combine like terms. X squared plus 5x minus 14. So we're going to set that equal to our x squared plus x. So we have x squared plus 5x minus 14. So I'm going to go ahead and subtract x squared from both sides, because I have that on both sides. It cancels. And we get x equals 5x minus 14. Let's go ahead and subtract the 5x from each side, because we already have all our constants on one side. X minus 5x is negative 4x equals negative 14. Divide both sides by negative 4. And this is not going to be a whole number, which is fine. Negative 4 divided by negative 4 is 1. So x equals 7 over 2. And if we look back at our original equation, x cannot be 7, x cannot be 0. Neither of those numbers is the answer we got. So those are acceptable answer for us to have. So that is our review for our exam that was coming up. As long as you are comfortable with these 10 problems, the test will be no sweat, because the test is actually easier than this review. So good luck, and I hope you all do really well. Have a good day. If you have any comments, any questions, feel free to leave them in the comments and I will get back to you. And go ahead and subscribe and ring the bell icon if you're interested in being notified when I upload new videos. Have a good day. Bye, guys.